Hello, everyone, and welcome to the Florida Springs Institute Field School. My name is Rob Mattson. I'm a senior environmental scientist with the St. Johns River Water Management District. I've been with them for over 15 years now, and before that, I was over 17 years as a biologist with the Suwannee River Water Management District. So I've been around for a while, and much of that has been working with springs. I've been a guest instructor with the FSI field schools almost since the very beginning in 2014. And they've had me give you a presentation talking about some of the water quality issues and the management framework in Florida Springs. And some of this information is going to overlap with some of the other presenters' information, and that's good. You sort of get things from a few different perspectives. So for this program, we're going to talk about water quality issues and management in Florida Springs. And let's try that again. There, okay. So I think, as you've already learned, springs in Florida, very, very unique resources regarded by a number of entities as imperiled because of their ecological value and other things. If you've ever seen, over the past year or so, some of my other presentations on springs and other venues, I usually start with some of the history behind springs. As I've said, before people came to Florida for the beaches, they came to Florida for the springs back in the days of the health spas and resorts. And then some of Florida's original tourist attractions were its springs: Silver Springs, Weeki Wachee. Springs have been affected, like unfortunately other Florida aquatic ecosystems, by a combination of hydrologic change and water quality degradation, as well as some of the other things like invasion by exotic non-native species and just generally being loved to death by public use. And the reason we've got springs in Florida is because of its geology, what the geologists call karst, which as a biologist, I say that's a geology based on limestone and what happens to limestone. So that karst geology of Florida is why we have springs. And it is also why springs are very vulnerable, particularly to water quality impacts, because what happens on the land, as we'll see, can impact the underlying Floridan aquifer, that big groundwater resource that feeds springs. And that in turn affects the springs. So in karst geology, land uses, what happens on the land readily impacts groundwater quality, which then affects springs, which then affects downstream aquatic resources, such as the streams that the springs help feed. Some of the major types of pollutants in general that we worry about when we talk about water quality degradation, and not necessarily all are relevant to springs, but many are. This includes the nutrients, primarily nitrogen and phosphorus, causing pollution, organic carbon wastes, toxic things like heavy metals, toxic organics like polycyclic aromatic hydrocarbons and PCBs, pesticides and herbicides, and kind of the new one on the block of the past decade or so, what we call emerging contaminants. These are things like the stuff that we put on and in our bodies, like pharmaceuticals, insect repellents like DEET, cosmetics. All of these things, when they get into water, they may act like hormone mimics. Endocrine disruptors is the fancy name we say. So those are some of the things we worry about when we talk about water quality degradation. With respect to springs, really the two biggies right now, the one that's been going on for a number of years is these increased nitrate levels that we're seeing in springs, which we measure as what we call NOx, or nitrate, nitrite, nitrogen. And those are some references there beneath the increased nitrate header that have reported on this, including some work done by Dr. Knight at the Springs Institute. And then kind of the new one emerging over the horizon is the springs are getting saltier. We're seeing these increases in dissolved ions, dissolved salts in the springs. And among this was really first brought to light in that report by Dr. Rick Copeland, retired now, but formerly with the Florida Geological Survey, regional and statewide trends in Florida's spring and well groundwater quality. It's a Florida Geological Survey bulletin. You can download it for free from the FGS website. And it's a report that I think needs to be, more widely known about and cited. So in terms of nitrate, these are some of the major springs in the St. Johns River Basin that I've been working with. And you can see the Florida Geological Survey considers the background or natural background nitrate to be 0.05 milligrams per liter or parts per million. And you look way down on this graph, just above the x-axis there, that white line, that's that background level. And you can see that for these 4 springs, Wekiwa, Rock, Blue, this is Volusia Blue Spring near Orange City, and Silver Springs, at one point in the past, pretty much all of them were down around that background, but now anywhere from 10, 20 times, even more higher than that. And we do know there are springs that are still around that background, particularly south of Palatka here in the Ocala National Forest, because these springs, their spring shed has always been forested. It's never been developed. It's never been converted into agriculture. In this case, the FGS background is that red line, that 0.05 milligrams per liter. You can see Silver Glen and Alexander are right around there. Juniper and Salt are a little bit higher. In Juniper's case, possibly because of atmospheric deposition, which is in part natural, but can be increased by air pollution. And that may be why Juniper is exhibiting what appears to be that slight upward trend in nitrate concentrations. But all of these springs we consider to be at a background or near background condition in the Ocala forest. Where's that nitrate coming from? Again, there are no really natural sources of nitrate in Florida and Florida's geology, except for a little bit of atmospheric deposition. So it's coming from us. It's coming from what happens on the land surface. This is some analysis that a private company did for us, for St. John's Water Management a few years ago, but they used a well network sampled by the U.S. Geological Survey. Those are those little red triangles. In this case, what we're showing in this map here is this is Rodman Reservoir at the top right here, and that's the Ocklawaha River running down the right side of the graph. Here's Silver River, and there's Silver Springs at the head of the Silver River, right smack in the middle of this map. And so what this is showing is areas of elevated nitrate concentration in the groundwater, in the Floridan aquifer. So we can kind of see this one hot spot to the northwest of Silver Springs, and then another one area of elevated nitrate in the Floridan aquifer to the south of Silver Springs. And it's interesting where this is coming from, that northwest hotspot. There's an aerial photograph. This is mostly agricultural land use, horse farms. That's what all those little squares are. This was taken in the wintertime, so most of the grass and kind of died back, but the little green squares are the fence line. So this is a heavy horse farming area northwest. There's also some areas here which I think this green area here and this kind of greenish area here, those are probably hay fields, area where hay is produced to feed the horses, and they fertilize the hay pretty heavily here to get multiple crops and to create a high protein hay product to feed these horses, many of which participate in horse racing. So the nitrate there is coming largely from these agricultural land uses. And then to the south, this is on the left side there, that's the community of Bellevue, south of Ocala. And I'm not sure if they're on central sewer or not, but you can see all around here, a lot more residential land use, the smaller subdivisions and such, housing developments. Here, this is the north end of Silver Springs Shores, which is a big planned community in southern Marion County. You can see it's a golf course community. You can see the greens, the fairways, and the greens and such. So all of those are fertilized. And then this facility here, this green circle, that's the city of Ocala, where they dispose of the effluent from their wastewater treatment plant, their sewage plant. So that's an effluent disposal field. So you can see the nitrate there is coming more from more urbanized residential, golf course, wastewater disposal land uses. So that's where the nitrate's coming from. Phosphorus is a little bit more enigmatic because Florida's geology naturally has a fair amount of phosphorus in it. Think about the phosphate mining that goes on in Florida, particularly down in the Polk County area and up in Hamilton County. H.T. Odom did a study back in the 50s looking at dissolved phosphorus in Florida waters, and he felt that your typical Florida spring had anywhere from 0.045 to 0.06 milligrams per liter of phosphorus. And you can see Silver Springs is right around there. Volusia Blue Spring, Rock Spring, and Wekiwa Spring tend to be a little higher. And that might be natural, although you notice somewhat of an upward trend in Wekiwa there. So that tells me that possibly some of that phosphorus, like the nitrate, could be coming from land uses on the land surface. But phosphorus is generally regarded more as a natural product. And then the other water quality issue that we had talked about was this increased salinization of Florida springs. Again, really sort of brought to light in this report by Dr. Rick Copeland of Florida Geological Survey publication. So what they did down at the bottom, they used water quality data from 57 springs collected between 1991 and 2003, and they did a lot of QA to make sure the data met their quality criteria. And what they found, and then they looked at the trends in a variety of dissolved constituents. They looked at alkalinity, which is kind of a measure of the hardness of the water. And then they looked at individual ions like calcium and chloride and magnesium. And for those 57 springs and for these different dissolved constituents, in generally half or more of the springs, they saw an upward trend, a positive trend using a statistical test. So here's some composite of data that I put together from Wekiwa and Rock Springs. This is conductivity, which is kind of another measure of the dissolved salts and ions present in the water. And you can see this very distinct upward trend in Wekiwa and a lesser upward trend in Rock Springs. And again, the Copeland work found this in a lot of Florida springs. This is actually not due to the fact that people are dumping salt on the landscape. This has to do with hydrologic change in springs and then in the underlying aquifer. Copeland and his co-authors attributed these trends to changing rainfall patterns along with increased groundwater pumping over the last 50 years, changing that pressure head in the aquifer, that potentiometric surface that you talked about when you talked about springs geology. And what's happening there is we're getting basically saltwater intrusion in one form or another, either intrusion along the coasts or upconing inland of the deeper, more saline water in the Floridan aquifer. So we're seeing some hydrologic changes here. Earlier, some of these changes were alluded to. On the bottom there, back in 2008, University of Florida published an extensive literature review of Florida springs, edited by Dr. Mark Brown and others. And chapter 2 in that report, which is available from the University of Florida Water Institute by Matt Cohen, alluded to he saw some of these increases beginning to occur. And then also in 2011, the very first Florida Springs Institute symposium, Joe Hand, a retired water quality analyst from the Florida Department of Environmental Protection, also called attention to some of these trends. So a number of folks have been looking at these. And so there's been documentation of the declining spring flows, and this all indicates hydrologic changes in the underlying aquifer, and these are responsible for those water quality changes. So those are really the two big issues having to do with water quality in Florida springs. We're going to talk more about how we've been addressing the nitrate issues. So a little bit of background on water quality law. at a federal level in the United States, goes back to the late 1800s. The U.S. Congress passed the Rivers and Harbors Act, which prohibited the discharge of garbage or other nuisance material into the rivers and harbors of waters of the U.S. And then in 1948, the very first Federal Water Pollution Control Act came along. And then subsequently, there were amendments to that act, culminating in 1972, which we generally call the decade of the environment because there was so much happened that decade. The U.S. Congress passed a series of extensive amendments to the Federal Water Pollution Control Act, which we called the Clean Water Act. And you've probably heard that. Among other things, it created the U.S. Environmental Protection Agency. And then subsequent to that, there were other amendments to the Clean Water Act, largely to incorporate the non-point pollution sources, the runoff from urban and agricultural uses. Here in Florida, the Florida legislature passed back in 1868 a law, a water pollution law, which prohibited defiling or corrupting water supplies, which included springs. In 1945, the State Board of Conservation was established, which was the main entity back then responsible for management of the water and other natural resources of the state. And then in 1967, the Florida Air and Water Pollution Control Act was passed, administered by a commission, the Florida Air and Water Pollution Control Act Commission. In 1972, again, decade of the environment, a big piece of legislation was passed, the Florida Water Resources Act, which created the water management districts, the 5 regional districts, and their regulatory framework. Not too long after that, the Florida Department of Environmental Regulation, DER, was created. In 1987, the Florida legislature passed the SWIM Act, Surface Water Improvement and Management Act. This was an effort to take more of a holistic watershed management approach to managing water quality in Florida. And it kind of got the water management districts into the water quality game. In the mid-90s, 1993, the DER, Department of Environmental Regulation, was merged with the Florida Department of Natural Resources to create the Florida Department of Environmental Protection. 1999, another big law, the Florida Watershed Restoration Act, was passed, focusing on TMDLs and BMAPs. We'll come back to that. And then finally, most recently in 2016, the Florida Springs and Aquifer Protection Act was passed, and we'll come back to that in a bit. So when we talk about Florida law, there's basically these two bodies of Florida law. There's the Florida statutes, which kind of give you the big picture. They lay out state policy, they provide general direction. They are promulgated by actions of the legislature, the Florida Senate and Florida House of Representatives. Then there's the Florida Administrative Code, which is more nuts and bolts, deals with regulations, rules, standards, implements the policy. The FAC is promulgated by agencies, executive branch actions. So some examples in the Florida statutes, there's Chapter 373, the Water Resources Act that I just talked about. And again, where you see that FS, where you see a chapter, whatever, FS, that's Florida statutes. So there's the Water Resources Act, there's the Pollution Discharge, Prevention and Removal in the statutes. There's Chapter 380, Environmental Land and Water Management. A lot of our land use, the land use codes and such are in Chapter 380, the local government land use codes and that kind of thing. And then Chapter 403, Environmental Control, that deals a lot with pollution management. Florida Administrative Code, that's that acronym FAC that you see after a chapter citation. So we've got the Water Resource Implementation Rule. I'll cite some of that. There's that's Chapter 6240 FAC, the SWIM Act, which after the legislature passed it, the rules relating to implementation of SWIM was Chapter 6243. The Surface Water Quality Standards, we'll talk about those in a bit. And then more recently, the Impaired Waters Rule and the Total Maximum Daily Loads. That was part of that Florida Watershed Restoration Act that was passed in the Florida statutes, mandated the development of these two, 62303 and 62304. So Following federal guidance in the Clean Water Act, the management of surface water quality sort of derives from what are called these designated uses, which that is something that is kind of set by policy. It describes the goal of the water quality standards for that particular use. So kind of the highest of those designated uses are the Class 1 water bodies here in Florida, which are surface water bodies used for potable water. In other words, water is withdrawn and used for drinking water. Now, that doesn't mean that the water is clean enough to drink directly. It still has to be treated to meet drinking water standards, but generally the highest, most protective water quality standards apply to Class 1 waters. Here in the St. Johns Basin, Lake Washington, down south of here in Brevard and Indian River County, that's a Class 1 water in the upper St. Johns Basin because the city of Melbourne withdraws water from Lake Washington for their municipal water system. You know, over on the Gulf Coast, a part of the Hillsborough River is a designated Class 1 water because there's a dam and a reservoir on the Hillsborough River that city of Tampa withdraws water from for their drinking water system. Then you've got the Class 2 waters, which are mainly coastal for shellfish propagation and or harvesting. These are areas where oystering or scalloping is allowed. Most of the waters in Florida are the Class 3 for fish consumption, recreation, propagation, and maintenance of a healthy, well-balanced population of fish and wildlife. At the federal level, it's what we call fishable, swimmable waters, Class 3. Then a few years ago, Florida created this Class 3 limited designation, recognizing that some of our water bodies are so highly impacted, you know, the entire watershed is all urban development. You know, the entire shoreline has been hardened and bulkheaded and such that they're never going to really be a natural water body again. So they created this Class 3 limited category to account for that. Then Class 4, that's primarily a lot of canals down in South Florida where they're used for agricultural water supply. And then Class 5, which I don't think we have any of those in Florida anymore, but these were water bodies pretty much that were given up to just use for navigation, utility, and industrial use. These were some of these were designated to allow the development of pulp mills and other industries that discharged quite a bit of wastewater back in the 50s to allow these things to come in. And then there's kind of this, over this designated use and water quality standards, there's this sort of extra level of protection on the bottom there called outstanding Florida waters. And these are described and listed in that 62302.700 in the administrative code. And the idea behind a designation as an OFW is they are supposed to receive some extra levels of protection, of water quality protection. In particular, there's this no degradation standard applied to OFWs, which is defined in the rule. By definition, outstanding Florida waters include all waters within national and state conservation areas, which includes parks, preserves, national forests, state designated aquatic preserves, and certain special waters as designated by the Environmental Regulation Commission, which is an appointed body which adopts the rules of the Department of Environmental Protection. And so if you go into, you know, the web, you can go to the state water quality, you know, all the state rules. And so chapter 62.302, that has the surface water quality standards. So it's this extensive table, which has, you know, on the left there, you can see, you know, the parameters from A to Z, from alkalinity to zinc. And then it's got the measurement units, and then for each of those designated uses, the applicable water quality standards, the either quantitative or otherwise, for each of these water quality constituents. Again, so you've got some for Class 1, Class 2, the Class 3 and Class 3 limited, and Class 4 and Class 5. In particular, for us, the nutrients are particularly important, particularly nitrogen and phosphorus. And those are even called out by rule. In the case of these, the standard here in Florida is what we call a narrative nutrient standard, and it's kind of a two-part. 48A there, the discharge of nutrients, I'll let you read that. And then part B is the one that's usually quoted, that in no case shall nutrient concentrations of a body of water be altered so as to cause an imbalance in natural populations of aquatic flora or fauna. And they're talking about things like causing algal blooms and that kind of thing. And this all pertains just to surface water. Interestingly enough, for groundwater, the federal and state drinking water standards apply. So springs have always been kind of weird because they've been that nexus between surface water and groundwater. So there's always been some debate. Do the surface water standards apply, or do the groundwater standards apply? In some instances, groundwater standards are more protective. In some instances, the surface water quality standards are more protective. So that's how in the water quality standards we have this narrative standard for nutrients. And so there's been, what exactly does, what's an imbalance, what's what is an alteration of nutrient concentrations, and so it's always been some debate. And so actually, in response to at least the threat of a lawsuit, several years ago, Florida adopted numeric nutrient criteria, some actual numeric standards. And they incorporated these in a little bit of a different way. They added some additional elements to Chapter 62.302 to the water quality standards, referred to as numeric interpretation of the narrative nutrient criteria standard. And so, and they've got two parts. 531 is for inland waters, lakes and streams and springs. And then they've got 532 on the bottom there for estuarine numeric nutrient criteria. But for lakes, they've got now numeric standards for total nitrogen and total phosphorus. Kind of varies whether your lake is a colored lake, got that tannic color versus clear, or whether it's a soft water lake versus a hard water, more mineral rich lake. For streams, it varies in different regions of the state, depending upon whether it's in an area with a lot of phosphorus in the geology. And then for springs, there's a nitrate concentration standard, which we'll talk about in a little bit. But so in essence, the nutrient standard in Florida is still that narrative standard that we looked at, but they have these additional elements of the Florida Administrative Code that give a numeric interpretation of that. So for springs, they adopted for nitrate as that NOx, 0.35 milligrams per liter, which is parts per million, or if you do the math, it's 350 micrograms per liter, which is parts per billion if you don't like decimals. And this was proposed and adopted, like I say, several years ago. These two, the inland waters and the estuarine numeric standards, but they were adopted back about 8 or so years ago. It was based on quite a bit of analysis conducted by DEP earlier in the 2000s, and they basically used the lines of evidence that they used to develop one of the initial springs TMDLs, which I'll talk about in a minute. That was the Wekiva TMDL, and you can get some of the supporting documentation for this at that URL down there. And I didn't check to see if this still works, but if it doesn't, please let me know. So how do we implement these things? There's kind of two mechanisms in Florida to take these water quality standards and actually put them into practice. The first one is one that I've been involved with, and that's called pollutant load reduction goals, or PLRGs. And those are defined in that Chapter 6240, the Water Resource Implementation Rule. And so I'll let you read that. I won't go and read it. But so PLRGs are mainly done by the water management districts, either as part of a swim plan. Some of the swim plans that have been done incorporate a pollutant load reduction goal, or as part of some type of a special basin management effort. And that's actually was what was handed to me when I first came on board at St. John's River Water Management District in 2005. A year earlier, the Florida legislature had passed something called the Wekiva Parkway and Protection Act, to enable the construction of a large highway in the Wekiwa Basin. And that act included a number of mandates, legislative mandates, to continue to try to help protect the Wekiwa River. And among other things, the St. Johns River Water Management District was instructed to do a plurb for the Wekiwa River, which was handed to me. So we used a multiple lines of evidence approach. We did, working with, among other folks, Dr. Bob Knight, we did some special studies to support the Wekiwa plurg effort. I looked at some of what other folks were doing in Florida Springs. In particular, a big study funded by the DEP was wrapping up, looking at nutrients and algae in Florida Springs. It was conducted by Dr. Jan Stevenson, who was with Michigan State University. And then I looked at what had been done in terms of other, what do other unimpacted streams in the southeastern US look like. Also looked some at nitrate toxicity. And these were the targets we developed for the Wekiwa Springs and River. About 0.2 or so micrograms per, or 0.2 milligrams per liter nitrate, or 200 plus micrograms per liter nitrate. And then for phosphorus, about 0.6 milligrams per liter, or 60 micrograms per liter phosphorus. These are based largely on limiting algal growth and proliferation in Wekiwa Springs and Rock Springs and in their spring run streams. So to actually generate the plurg, the pollutant load reduction goal, we took those target concentrations. So these were the target concentrations. We said this is what it needs to be at to be healthy, and so we applied the target concentrations to what it was at the time in 2005, 2006 when we did this work. And on the very right there, that column on the right in red, those were the percent reductions that we had calculated. So those were the actual plurgs that we got. So the thing with a plurg is it's not enforceable. It does not have the force of law. So the Wekiwa Parkway and Protection Act also mandated that once we did a plurg for the Wekiwa system, that the Florida Department of Environmental Protection was then to take that and do a total maximum daily load, or TMDL. And they're quite similar to a plurg. Basically, they determine, how much nutrients or other pollutants you can put into a water body and still meet the applicable water quality standards. And that is, of course, from the TMDLs were initially specified in the Clean Water Act. So this was the guidance that Florida is following from the federal. And then the DEP actually has a process for doing TMDL. This was actually laid out in 62303. That's the impaired waters rule that I mentioned earlier. It kind of lays out the process for doing this. To do a TMDL, a water body has to get on this verified impaired waters list. And then they go through a process. And once they adopt the TMDL, they implement it through a BMAP, a Basin Management Action Plan, which you might have heard that acronym. And a TMDL is enforceable, okay? There is a force of law behind it. So the way it worked is we prepared a report describing how we did the plurb for the Wekiwa system, which included Wekiwa Spring, Wekiwa River, Rock Springs, and Rock Springs Run. And DEP used our report to place the system on that verified impaired waters list, in this case, because of a violation of that narrative nutrient concentration. At the time, the 0.35 had not been adopted yet. So they used the targets we developed in the plurb. The pollutants of concern were nitrate and total phosphorus. And so basically, I worked with Dr. Yujing Gao, who at the time was with DEP. I believe he's with Florida Department of Health now. But I basically gave Dr. Gao all the data we had used to do the plurb. And they hired some researchers at FSU, and they went through their process and developed a TMDL based on that. And that Wekiwa TMDL was officially adopted by the DEP secretary in April of 2008. And so they came up with a target a little bit different from ours. That's that middle row in this table. Their target was about was 0.286, about 0.29 milligrams per liter, or 286 micrograms per liter, and similar to us. So they developed the target. They compared it to what the existing condition was when they completed their TMDL in 2007, and so they got some fairly similar percent reductions that we did for nitrate. And you can download that URL at the bottom there, and I believe that is still an active URL. You can get the TMDL report, which describes the process they went through and the data they used. For total phosphorus, again, their target was a little bit higher than ours, 0.065 milligrams per liter, or 65 micrograms per liter. Again, they came out with some similar percent reductions for phosphorus. Again, we didn't quite know whether phosphorus is natural or not, but both in the Wekiva Spring and Rock Spring, it's quite a bit higher than that sort of natural background that Odom came up with in the 50s. So we thought to go ahead and add a TMDL for phosphorus. Most of the other springs TMDLs just focus on nitrate. So again, TMDLs are implemented by doing these Basin Management Action Plans, or BMAPs. So DEP convened a working group to develop the Wekiva BMAP. They focused mainly on nitrate, assuming that if you reduce the loading of nitrate to the landscape, you'll also reduce phosphorus. We thought that's a reasonable approach. And so the BMAP for the Wekiva system was initially adopted in 2015, again by the order of the Secretary of DEP. And then just a few years ago, in 2016, in a continuing effort to deal with the problems besetting our springs, the Florida legislature passed the Springs and Aquifer Protection Act in 2016. That was incorporated into as Part 8 in Chapter 373 in the Florida statutes. It designates this category outstanding Florida springs, which in the legislation were defined as all first magnitude springs, either those currently or those that were historically designated first magnitude. Fanning Springs would be a good example. And then by name, they included some key second and third magnitude springs: Wekiva Spring, Rock Springs, De Leon Springs down in Volusia County, Gemini Springs, also in Volusia County, Poe Spring in Alachua, and Peacock Springs in Lafayette County. So these are all outstanding Florida springs. And then the act had a number of mandates in it. It required the water management districts to develop minimum flows and levels for all outstanding Florida springs. And in terms of water quality protection, focusing on the nutrients, the nitrate, primarily the nitrates, it required DEP to adopt TMDLs and BMAPs for all outstanding Florida springs. As part of this, they were to take the spring shed of the spring and delineate these PFAs, priority focus areas. And then within those, the act included some additional restrictions on OSDS, which is on-site sewage disposal systems, aka septic tanks, new domestic wastewater facilities, sewage treatment plants, agricultural practices, hazardous waste disposal facilities, and biosolids application. The biosolids is a kind of a nice name for sewage sludge, basically the stuff that's left over after the sewage treatment process or that's pumped out of septic tanks. Having to do with land application of that. The requirement was that DEP had to have this done by June 29th, 2018, or actually by July 1st, 2018, and they did meet that by a couple days. The BMAPs had to include a remediation plan for hooking up septic tanks to some kind of a sewer system under certain conditions, which I won't get into the weeds too much on that. So the DEP has been working on that, although a number of these BMAPs were challenged by folks having some concerns about whether they were protective enough. And we found out about a couple of weeks ago that the hearing officer in that administrative challenge basically issued a final order favoring the department, the DEP, saying the BMAPs could go into effect. So hopefully now we can move forward with that. But that involves, implementing projects in these priority focus areas or somewhere in the spring shed to reduce nutrient loading, the massive nutrients, primarily nitrogen, being applied to the landscape, just like going back to the beginning of my talk. Also reducing groundwater withdrawal to try to protect and restore spring flows. And landscape irrigation is a factor that can increase recharge of nutrients to groundwater. And then also projects that increase the recharge of clean water, low nitrogen, low phosphorus, to the Florida aquifer. And so some examples, this is a relatively new project that we started that the Water Management District, in cooperation with local governments, started a little over a year and a half or so ago. This is an old sand mine near Volusia Blue Spring. So, if you go down 17 to Orange City and you head west on French Avenue there, out of Orange City, heading towards Blue Spring, just before you go over the railroad overpass and get to the entrance to Blue Spring State Park, on the left there's this old sand mine. So the district helped acquire it, and we're working with the municipalities in the area, Orange City, DeLand, Deltona, to funnel stormwater to this facility along with some reclaimed water and run it through wetland treatment areas, and then to some some old sinkholes to recharge the groundwater to help maintain flows in Volusia Blue Spring. So that's an example, and a lot of that's being funded with district dollars as well as local government dollars. And then this is one some of you are probably familiar with, just recently completed by City of Ocala, the Ocala Wetland Treatment or Wetland Recharge Park to help Silver Springs. Very similar, stormwater and some reclaimed water run through wetland treatment areas, and then to sink features or paleo sinks to recharge the Florida aquifers. So those are some examples. So to kind of wrap it up, surface water quality is protected using water quality standards or criteria, and these are derived from designated use. So that designated use sets the standards. So a class 1 water body has the standards to protect the class 1 water body. It's not based on what the water quality is to begin with. And some folks kind of get those two things confused. A water body is a class whatever because it's got this water quality. No, because it's a class whatever, it has to meet these water quality standards. So the again, for nutrients in Florida waters, we still have that narrative water quality standard, but the state has sort of supplemented that with these numeric interpretations for lakes, streams, springs, and estuaries. And that's been in place now for actually a little over 6 years. Numeric nutrient criteria can also be developed separately through the TMDL process. And I believe so the ones we developed for Wekiwa through the TMDL, they still apply. They have not been eclipsed by the 0.35. And then I believe Weeki Wachee Spring also has kind of its own specific nitrate numeric criterion derived through the TMDL process. Then there's another process, the SSAC, Site-Specific Alternative Criteria, that can also set alternative standards. In general, just based on the work I've done over the years and talking to other springs guys, spring scientists, protective nitrate criterion is going to be between 0.2 to 0.4 milligrams per liter. It's not, as low as that natural background, but I think it is protective. And the 0.35 falls in there. The TMDL definitely falls in there. A lot of phosphorus is natural, but is it all natural? I don't think so. I think some of our springs, that along with the nitrate that's getting in there, they're getting some phosphorus. And again, kind of an emerging water quality issue is the springs are getting saltier, and that's a hydrologic situation. That's not like we're dumping salt on the landscape like they have to do up north, during snow and ice storms. And that seems to be due to Changing rainfall patterns, probably due to climate change, just not getting the recharge that that the Floridan aquifer needs, and kind of the adding insult to injury, the groundwater pumping, changing that pressure head in the aquifer to where we're getting that salt water, upconing or intrusion. And so there's some of my contact info, phone number and email, and I do appreciate your attention, and hope this program was useful and informative.